Now, what are the structural supports that we have? So I would be sharing with you certain pictures that will explain to you what is a roller support. Now, if this visible, is this visible to you? The picture on the right
Yes.
side.
Yes, sir.
The picture on the right side. Now, this
Yes,
picture
Yes,
on
sir.
the right side is a roller support. What happens is that during, if I draw over it, this will tend to move along this direction. So it would tend to rotate over the roller support. This is a roller support. Next, we have an example of a fixed support. Now, in a fixed support, something like this. Now, if I zoom it up, now this is fixed support. It's fixed to the wall here. So it becomes a fixed support. Then the third one is the hinge support. Now, this is a very good picture of a hinge support. There is a truss here. This is the abutment of the truss. ये abutment है truss का. बीच में एक rod डाली हुई है, about which it's rotating. Now this is a hinge support. Now there can be two types of hinge. This one is a support, यानी कि end पे है. Support is always an end connection. Then there is an internal hinge, which we are representing like this. Now you must be knowing about this. This is roller. This is a roller support. Now this is an internal hinge here at this location, and this is a fixed support at the end. Right? Is it clear up till here?
yes, sir.
Yes, sir.
Now I would like to go into what is there is a one more support that we can talk about, and that is an internal, just write down internal support. When we are talking of an internal support, I think it's not here. Just a minute. So about each one of these supports, what I would like to show you is that all of these supports have reactions. Now first, the fixed support. Now what are the reactions in each of these supports? When we are talking about fixed support, now this is a fixed support. There are three reactions here. Now this is the first reaction here. That's a moment. This is the second reaction here. That's vertical translation. This is the third reaction. This is horizontal translation. In a roller support, you will get only one reaction in the vertical direction. इस direction में ये it's free to move. So there is a degree of freedom in this direction. For pinned support, there are two reactions. One is a vertical reaction here, and another one is the horizontal reaction at this point. So these are the main three supports that we would be discussing. And further, what we know is that in a roller support, how many degrees of freedom are there? One is horizontal.
So
And
2 degrees.
so there are 2 degrees of freedom, one being horizontal and another being rotation. In fixed, there are 0 degrees of freedom. In pinned,
Freedom.
there is 1 degree of freedom, which is
1 degree.
the rotation. There is one, that's rotation. So after knowing the degrees of freedom of all these three supports and the reactions, so we now know there are three reactions in fixed and 0 degrees of freedom. There is one reaction vertical in roller and 2 degrees of freedom. In pinned, there are 2 degrees of freedom, and there is there are two reactions and 1 degree of freedom in the pinned connection. So there are more who have joined us. Roll number 4. Roll number 4, Asif. Asif.
Yes, sir.
I just want to see your face. ताकि मुझे पता चले मैं किन को पढ़ा रहा हूँ.
Okay, sir.
आपको पढ़ाया है इससे पहले कंक्रीट टेक्नोलॉजी?
Sir. Yes, sir. Yes, sir.
Right. Then we have Ahrar. Ahrar, roll number 10. So you are Ahrar. Then who else has joined us? Umar, Khalid, server was here. Okay. Now, knowing that the degrees of freedom, we were discussing about the degrees of freedom and the reactions. Next, we move to the indeterminacy. What is indeterminacy now? First of all, I would like to share with you a slide. Now, if indeterminacy is, I told you indeterminacy is the excess of the reactions that are needed. They are the excess of the reactions that are needed to solve a particular structure. Now, if this indeterminacy or the static indeterminacy, we also call it, if it's equal to 0, then it's determinate. Right? Is this visible what I'm writing?
Yes, sir.
Yes, sir.
If this is greater than 0, then it becomes indeterminate. Now, if the same thing, static indeterminacy, if it's less than 0,
Unstable.
then it's unstable. Now, how do we calculate indeterminacy? There is a very simple formula to calculate indeterminacy for any structure or the static indeterminacy. Now, that formula is it's alpha to any equal alpha. Okay. It's alpha into m plus R into beta, just a minute, it's beta into J plus gamma. Now बीच में there is minus here. So this is the equation to determine static indeterminacy. It's a general equation that you can use anywhere in determining the static indeterminacy of the to determine the static indeterminacy. Now, what is alpha here? You can write down alpha is alpha. What I'm talking about is number of actions in a member. I'll explain to you what are the number of actions. M, what is M? M is number of members.
Members.
Then third is R. R is number of reactions. Then we have beta. What is beta here? It is number of equilibrium equations which are available at any joint. Then J is number of joints. Then lastly we have gamma. What is gamma here? It's the number of releases. So this is what we have until now. This is a general equation. Now what is alpha? Number of actions in a member. What is an action in a member? The action in a member is what you are imposing on the member. Now the action in a member could be, it could be one, it could be shear force, it could be bending moment, or it could be axial force. These are the actions in a member. The three primary actions that happen in any member: axial force, bending moment, and shear force. These are the actions and these are alpha. So if all three are acting, shear force, bending moment, and axial force, then the number of actions are 3. Now if only axial force is acting, like in column, then the number of action would be only 1. Similarly, axial force only is the only acting force in truss. So shear force, bending moment, and axial force, you will get all 3 of these in beam. Beam में आपको ये 3 मिल जाएंगे. Axial forces would be mostly predominant in column as well as truss. So in columns and trusses, you can have only one action if the column is the only supporting, if it's not joined by beams or other things. Then next we have, and if the column is concentrically loaded, then we have only axial force there. Next is the number of members. Now that I will explain to you once we do a question on this. Number of reactions. What are the number of reactions? Now reactions are offered by what? They are offered by supports. The reactions are offered by the supports. We just discussed what are the various supports that we have. We have a roller support, we have a hinge support, and we have a pin support, and we have a fixed support. So all 4 of these have different form of reactions. Then beta is the number of equilibrium equations. Now how many equilibrium equations are there? There are mostly 3 If I write it down, just a minute. It's summation of mx equal to 0, and then we have summation of fx equal to 0, and then we have summation of fy equal to 0. Now this could be mxy equal to 0. Now here, if we have look at this, this would be in a 2D frame, or in a 2D beam, or in a 2D column structure, or a 2D truss structure. These all three equations could be acting. But for regarding trusses, I will go on later. There are no moments equilibrium equations. That I'll explain to you later. In frames, what do we have? In a frame structure, we have, let me take a new slide. First, you have the supports at the bottom, these being the supports. Then you have internal connections somewhere here. You have the internal connections here. These are the elements. These three are the elements. Now this is a beam, this is column, and this is column. Now if this is hinged, first of all, if this is hinged, then if this is a roller, this is roller. Now can you tell me, any of you, how many reactions would there be at the hinge support here?
2.
There will be how many?
2 reactions.
Two reactions. One this and the other one being this one. Now in the roller support, you would have how many reactions? This one.
1 reaction.
There will be one reaction, this one. Now in this frame, you have 3 reactions. Apart from that, you have the internal reactions here at this point and at this point. Now how many internal reactions would there be at these 2 points? How many internal reactions would there be at these 2 points? Will there be any reactions at internal joints?
Yes, sir.
कितने होंगे? In 2D frame. We'll go to this later. First, we'll start with a beam. The example of a beam. There were certain more things in that. Just a minute. The other things that you need to know is related to what is beta. Now these are 3 number of equilibrium equations that we mostly have. Next is number of joints. The number of joints in a particular frame or a beam or a truss. Support is also included in the joints. Then we have gamma, which is the number of releases. Now, where does a release come? Release comes in internal hinge. Release comes in an internal hinge. Now, if you have a system like this with an internal hinge here, then there would be one additional release at this point. There would be additional release at this point. At this point, you would have one additional release. So the number of releases for internal hinges, number of releases at internal hinges equal to number of members at the point of internal hinge minus 1. So how many members are there here? There are two members, aren't there? One is this member is one member, this is the second member. So there are two members here. So the number of releases would be 2 minus 1. So overall, the number of release at one internal hinge is 1. It's 1. You will all rejoin in this session. ये session close हो रहा है. You will rejoin. All right.